In order to create and apply a filter in frequency domain for a two-dimensional image, it is very similar to applying a filter in frequency domain to a single dimensional signal. The only primary difference is that with an image, you have the center of the image being the low frequency area. So the center of the image and the circular area around it represents all of the low frequency signals, and everything radiating outward from the center represents the higher frequency domain for the image. In order to create a filter that would work in 2 dimensions for frequency domain, we have to first create an algorithm that will calculate the distance for every single point in the image that we have in frequency domain. Now here I have created a new matrix that is the same shape as the image in frequency domain, and we will be iterating over the size of this image, calculating every single the value at every single point in the image based on the distance from the center of the image. And then we can assign values based on that distance. Do note that this distance is not exactly tied with frequency, and any values that we have here for a filter are more or less arbitrary numbers. And in order to apply the filter, it is the same way we had with one-dimensional frequency domain filters. We just have to multiply the frequency domain image with the filter, and the result needs to be brought back from frequency domain into time domain. To better understand the filter, I will also add that as one of the things that will be plotted. Now, as you can see in the image, there are a couple of artifacts. One of them is that the darker areas of the image have very white values, and white areas of the image have very dark values. Now, this is caused by some values going into the negative range and some values going over the maximum value that can be represented as an image.